Hello everyone! Welcome to ComBoox. In the following video, we will introduce how to transfer shares to external shareholders in the ComBoox system. For demonstration purposes, we are operating in the test system. The operations in the official system are the same as those in the test system. First, we need to retrieve the target company from the system. Once we enter the target company's homepage, let's take a look. Currently, this target company has 4 shareholders, holding shares numbered 1, 2, 3, and 4. For convenience, we will refer to them as shareholder number 1, number 2, number 3, and number 4. Let's assume that shareholder number 1 wants to transfer a portion of their shares to an external shareholder. The first thing to do is for this shareholder, as the proposed transfer, i.e., the seller of the shares, to draft a share transfer agreement, we need to switch to the Register of Agreements section. The investment agreement register records all historically executed investment-related agreements associated with the target company, including both agreements for issuing new shares and share transfer agreements. Share transfers can be divided into 2 main categories. Transfers from shareholders to external investors, commonly referred to as external transfer arrangements. Transfers between existing shareholders, internal transfer arrangements. Now, assume that shareholder number 1 who holds share number 1 wants to transfer a portion of their shares to an external user. Since their MetaMask account is account 6, we will call them user number 6. First, they create an investment agreement. After clicking Confirm, we can see a new row added to the investment agreement list. This row points to the cloned contract of the investment agreement we just created. We won't go into details about the cloning mechanism and proxy calls here, as they were introduced in previous videos. We can see that the status of the smart contract clone is created. Clicking the hyperlink in the first column takes us to the investment agreement user interface. This is the investment agreement user interface. As introduced in a previous video on drafting shareholder agreements, there are 5 main sections. We won't repeat them here. To edit or draft this investment agreement, we first need to appoint an external lawyer to operate. Of course, if the shareholder has the necessary business and legal knowledge, they can also appoint themselves as the lawyer for the smart contract. Why do we create a lawyer role group and its administrator, the general counsel? This is to introduce external lawyers in large-scale transactions, allowing them to review drafted clauses one by one and ensure that the smart contract terms remain consistent with the naturally drafted text on all key information. Note that the lawyer group's authority is limited to drafting clauses. Whether the clauses can be finalized and meet the needs of shareholders or investors must be confirmed by the shareholder who created the smart contract. That is, the finalization action must be triggered by that shareholder. In the access control section, assuming shareholder number 1 is also the lawyer, they appoint themselves as the general counsel, the head of the lawyer team responsible for drafting the smart contract. This allows shareholder number 1 to directly edit the details of the agreement clauses. We switch to the body terms section. Here, the main information to be filled in the investment agreement is how to define a transaction. In the Create Deal section, the first attribute is Type of Deal. There are several options: capital increase, external transfer, and internal transfer. Since we want to transfer shares held by shareholder number 1 to an external investor, we choose the second option, Transfer External. The second attribute is the share number you are transferring. Since we checked earlier that shareholder number 1 holds share number 1, the system will automatically retrieve the share class, price, and other information from the backend. Assume that during the transfer, the shareholder wants to recover some investment returns, so the transfer price becomes 1.5. The parameter price paid in the share transfer context means for the paid-in portion of these shares, each dollar of paid-in capital corresponds to a price of 1.5, representing a slight premium. Closing deadline defines the deadline for completing this specific transaction. We usually set 90 days, which is sufficient, but we can set it more broadly here. For example, September 22nd, 2026. For the potential buyer, we enter user number 6's own system ID. Since this user is an independent investor with no other related parties becoming shareholders of the company, we directly fill in user number 6's ID in the group of buyer field. The number of shares or amount to be transferred is simply set to 1,000 shares, i.e. $1,000 of capital contribution. Then we click the Add Deal button. Below, we can see a new row added to the transaction list, representing the transfer arrangement we just filled in. Clicking this row brings up the details of this specific transaction. Most of the content is what we entered earlier. Voting weights are directly retrieved from the system for that share class as set during initialization. Note: if we had selected a capital increase transaction when defining the deal type, there would be a specific field allowing us to adjust the voting weight of the newly issued share class. However, for share transfers, there is no need to re-enter this information. Let's close that. The next steps are similar to general inter-shareholder agreements. Let's define the signing schedule for this agreement. For example, we require the agreement to be signed by the parties within 1 day and closed within 90 days. We enter 1 in 90, confirm, and it is written into the system. For the parties, the buyer is user number 6, not yet a shareholder, and the transferor is shareholder number 1. We add both user IDs to the signature page. Next is the lifecycle control. Assuming both old and new shareholders have reviewed all contractual terms, we can directly finalize the draft agreement, i.e., click Finalize IA. Once confirmed, the addresses of the previously authorized lawyer and lawyer group become 0 addresses. Also, the agreement creator, the user authorized to create the smart contract lawyer group, also becomes a 0 address. This means no further modifications to the clauses are allowed. All future process control, voting, or performance will be directly managed by the smart contract without any possibility of human intervention from external accounts. We then refresh the system, exit, and re-enter. Now the status of the agreement has changed. The access control panel and tabs disappear. Clicking into the lifecycle section, we see that the second step is a circulation process. This means that the shareholder who drafted the agreement sends it to the parties who need to sign, and they complete the signing on-chain, naturally, using digital signatures from their controlled wallets or electronic signature algorithms. In this specific circulation process, we have the 256-bit byte arrays. The purpose is to fill in 2 different hash function values. For the upper one, we recommend filling in the hash of the storage location of the electronic agreement data. For example, it might be stored on a company internal server, and we can set access restrictions so that only specific users can log in and view the original text. We can take such a domain address or IP address as input, compute its hash value, and fill it here. This provides a hash pointer for future reference when verification of the natural language text is needed. Alternatively, and this is more recommended, we can upload the naturally drafted electronic document directly to the IPFS system, the interplanetary file system, a distributed, decentralized storage solution. Large amounts of data can be stored on IPFS. IPFS has a special addressing mechanism. It no longer addresses by domain name or IP address, but by the content of the file itself. It also uses a hash function as the algorithm, takes the electronic file as input, computes a specific hash value, and uses that hash value as the addressing label, guiding users to download or retrieve the target data in IPFS's distributed system. This target data can be directly drafted and uploaded in natural language, and encryption measures can also be added. For example, we can use asymmetric encryption so that only those with a specific private key can read the text. Or we can use symmetric encryption, share the key among shareholders, and let specific parties download the document locally, and then decrypt it. We can also use special encryption mechanisms like PGP, First, encrypt the symmetric key itself with asymmetric encryption, then send the twice encrypted key to specific parties, allowing them to first decrypt obtaining the symmetric key, and then decrypt the target file, finally obtaining the natural language agreement. The core idea is we can store naturally drafted electronic documents outside the blockchain, so that the summary or key data parameters stored on the blockchain for the investment agreement can find a more detailed version described in natural language. As for whether the naturally drafted electronic document or the blockchain-based investment agreement is legally binding, this is a freely settable commercial arrangement. We recommend treating the blockchain-based investment agreement as the binding text. At the same time, the natural language agreement can also be signed and have binding effect. However, if there is a conflict or inconsistency on key data between the natural language text and the key data recorded in the smart contract on the blockchain recorded investment agreement key data shall prevail. If that is done, the on-chain information is given priority. In the future, if the company conducts other fundraising arrangements or even goes for a public listing, the on-chain company book information and investment agreement records will have clear binding effect. For investors, this is more secure, reliable, and decentralized. Alright, after all that explanation, let's do a simple demonstration. For example, we go online and find a suitable hash function online calculator. Simply input some short, natural language sentences. Use the online calculator to compute a hash value, and use it to represent the hash of the relevant electronic document, the naturally drafted electronic document. This is just for demonstration. We click the copy button, and the automatically computed hash value is copied to the clipboard. The hash algorithm we use is Keycock 256, which is the same default hash function used by the Ethereum EVM. This makes it easier in the future if we need to use some smart contracts for on-chain automatic control. It will be convenient to verify the hash mapping relationship between input data and the function value, especially when setting up hash locks. Now, after copying it to the clipboard, we go back to the circulation interface and paste the hash value into the second field. This field is specifically reserved for storing the hash value of the naturally drafted electronic document. The previous field, as introduced, is mainly for confirming the storage location of the electronic document. Of course, if stored on IPFS, there will be a hash pointer that can be used for content-based addressing, making it easy to download. We click the Circulate IA button. This links the on-chain investment agreement drafted with the smart contract to the off-chain electronic document. Off-chain can mean either online or centralized offline storage. However, this link is only for reverse verification. It is difficult to find the file or understand its content through the linked hash pointer. But when you do know the file content, you can easily verify using the hash function, whether it is the specific electronic document that generated that hash value. This is a different logic. Good. We see that the system has moved to the next step. The next step is the signing phase. Similarly, the seller shareholder, number 1, as the drafting party, can leave his handwritten signature in this signing step. For example, he makes a color scan, produces a PDF file, then hashes it and fills the hash value here. He can also store his signature on the company's server or upload it to IPFS and write the relevant hash value as the on-chain hash pointer of the signature directly into the blockchain. This allows for effective identity verification in a more extended scheme in the future. We can slightly rephrase this sentence. User number 1 signs the investment agreement. This represents a handwritten signature or a red chop stamp scanned in color, then hashed. We copy its hash value to the clipboard and paste it into this position. This writes a hash pointer of a signature directly into the blockchain, representing that the seller of the investment agreement has signed. We can look at the reminder field below. It records the parties to the contract. There are 2 parties. The numerator part indicates how many signing parties have already signed. Now it is one of 2, meaning one of the 2 parties has completed the signing. We switch to the potential buyer user number 6. He also agrees with the relevant clause settings and can correspondingly sign his own signature. During demonstration, we change the last character to 5, and the hash value changes significantly. Then we sign. In this way, the system directly stores the hash pointer of user number 6's signature on the chain for future verification. After both sides have signed, the system automatically moves to the next step. The next step is to submit the investment agreement to the shareholder meeting for review. The shareholder meeting will retrieve the currently effective shareholder agreement provisions and see which procedure and which voting rule should apply. For an external transfer arrangement like this, the system defaults to directly applying the second voting rule. The executor here means, if this investment agreement is regarded as an electronic file or a legal document, who will execute it on behalf of the company or on behalf of the parties? This becomes more meaningful at the shareholder agreement level. After the shareholder agreement reviews and approves it, a special activation arrangement is required. This activation process must be triggered by the specific user we fill in as the executor. If another user tries to do it, they cannot activate the particular shareholder rights. We need to make that clear. So, we assume shareholder number 1, the seller in the transaction, sets himself as the executor and submits it to the company's shareholder meeting for review and voting. But the system tells us that an internal error has occurred. That is because we are currently in the DAT exercise period, the drag along and tag along rights exercise period. So it is not yet time to submit to the shareholder meeting for a vote. Why is this setting here? We introduced it in a previous video. If special shareholder clauses include drag along, tag along, anti-dilution, or preemptive rights, the system automatically retrieves the relevant schedule from the shareholder agreement and calculates whether the submission to the shareholder meeting is allowed now. Typically, these shareholder exercise matters need to be arranged before the shareholder meeting voting procedure, i.e., they must be exercised before the vote. So let's first switch to the investment agreement register view and check the timeline of the investment agreement itself. We can see that the circulation date is July 7th and the closing deadline is October 5th. Let's look at the more detailed schedule. The signing deadline is July 8th, the next day. The preemptive rights exercise deadline is 1 day, July 9th. The tag-along and drag-along exercise period is July 10th. Therefore, if we want to submit this specific agreement to the company's shareholder meeting, we need at least to advance the on-chain time to July 10th before submission is possible. Because this is a test system, we can directly enter a specific command in the console to advance the test network's time by a certain amount. We enter the command to advance the on-chain time by 3 days, so that the on-chain time satisfies the schedule requirements of the shareholder agreement for the investment agreement. Then we mine a new block, recording the new timestamp on the blockchain. We switch back to the panel we were just on. This time, we switch to Program Control, enter shareholder number 1's ID, and click Propose. Now we can see that the shareholder agreement's schedule requirements are met. After this period of time, the relevant rights holders have not exercised their rights. So shareholder number 1 can directly submit it to the company's shareholder meeting for the shareholders to review and vote. Continue to switch to the General Meeting Minutes interface. The GMM General Meeting Minutes user panel directly integrates all categories of matters that need to be discussed, voted on, and reviewed by the company's shareholder meeting. We can see that in the lower panel, all motions that are being discussed or have already been voted on are listed. Currently, there is a new motion with the status proposed. We click to open this motion. The voting schedule of this motion lists several key dates. We see that the voting start time is July 11th. The current on-chain time is July 12th. This means we need to advance the time by 1 or 2 more days. Below, under Actions on Motion, users can choose Cast Vote to vote on the motion. Alternatively, users can vote in the corresponding investment agreement's lifecycle section. Now we go back to the test system, advance the on-chain time by another day, and mine a new block to record the new timestamp. Then we come back. If we continue to choose shareholder number 1 to sign, the system will report an error, because this shareholder is a party to the agreement. The system applies a recusal rule, so this shareholder cannot vote. We switch to account 1. Account 1 fills in the hash of his signature, clicks Confirm, and chooses support for this motion. Confirm. Now we can see that the voting status below has changed. We switch to Account 3. Special cases like delegated voting or voting against, we won't demonstrate them. We assume everyone has already communicated, so Account 3 also votes in favor. He directly inputs his own signing hash and votes in favor. Account 4, and so on. I won't repeat it. Now we can see the voting results, and the attitude is all in support of this motion. The square on the left is a link button. We click in to see the details. For example, the first row account, one who voted in favor, user ID ending in BB87A_82EDO, represents a rights holder with a total voting weight of 80,000. The voting date is July 11th. Block number 539, and then the simulated hash value we wrote earlier. Our company has 4 shareholders in total. Shareholder number 1, as a related party signatory, must recuse himself. The remaining 3 shareholders, we assume they all voted in favor. When can we get the voting result? By default, the system requires waiting until the voting period ends. We know the voting period is 1 day, so we advance the system time by another day. Then we switch back, and shareholder number 1 as an interested party spends some on-chain gas to advance the procedure and calculate the current voting result. Only after the voting result is calculated can subsequent legal actions be carried out. That is, the status of the smart contract for the voted on matter can change. We can see that the voting has now ended. The motion status has become approved. Then we go back into the specific investment agreement. Now we can see that the related transaction status has changed. The status is now locked. This locked status was actually set directly at the seller's signing step. That is, if the transfer of shares signs a share transfer agreement, then the paid-in portion corresponding to that share amount becomes locked. This prevents the so-called double selling or repeated sale of the same shares. Next, we can attempt to directly settle the share transfer. We now choose a slightly more complex settlement method. As the transfer, shareholder number 1 chooses to lock the target shares directly into a hash lock, push to coffer. What does that mean? It means putting the target shares into a safe. How do we lock this safe? We directly create a hash lock, input a simple natural language sentence. For example, today is Monday. Copy the corresponding hash value and record it on the blockchain as the hash lock. In the future, the buyer will pay some fiat currency offline, for example, through a traditional bank account to the seller as consideration. The seller can then tell the buyer the hash key, that is, the simple, natural language sentence we just input. The buyer can input this hash key to unlock the lock, and the system will automatically change the holder of the locked shares on the share register to the buyer. User number 6. Behind the scenes, the system actually cancels the corresponding capital contribution and issues a new capital contribution certificate to user number 6. This is quite similar to issuing a new capital contribution certificate to a new shareholder in normal business activities. The closing date here actually sets a specific expiration date for the share hash lock. The buyer must input the corresponding key before the expiration date to unlock the lock and have the target shares transferred to him. If it expires, even if the buyer has the key, they cannot obtain the locked shares. After expiration, the seller can also unlock the corresponding shares through a specific API, removing the encumbrance and restoring the shares to a normal disposable state. That is, the clean paid parameter without any encumbrance will be restored, allowing the seller to dispose of them in other ways. We previously advanced the on-chain time to July 12th, so we set this hash lock to expire on December 12th, 2026. We copy the hash value again and click Lock Share. The system will lock the target shares into this specific hash lock. In fact, there are some parameters not displayed here, but directly filled in by the system. For example, who can unlock the target shares, and to which username the target shares will be transferred. Why is that not written? Because this is a specific share transfer transaction system that can directly retrieve the buyer's user ID from the backend, so there is no need to fill it in manually. Now we switch to user number 6, the buyer. According to the logic just introduced, he enters the #locks key. That is, the short sentence we just entered, "Today is Monday," copies it to the clipboard, pastes it into the corresponding key field, and then clicks Pick Up Share to extract the locked shares. Let's see what changes occur in the system. After the buyer inputs the key and clicks to pick up the shares, the status of this specific transaction under the investment agreement becomes closed. Let's first look at the shareholder register. The shareholder register has automatically changed. A new shareholder has been recorded, holding shares with paid-in, subscribed, and clean amounts all equal to 1,000 United States dollars. If we click Investment History, it will show the investment track of this shareholder in this specific company, his investment journey. He directly settled the shares on July 12th, obtaining 1,000 United States dollars of paid-in, subscribed, and clean capital contributions. Alright, so far, we have demonstrated how to arrange and execute a share transfer transaction in the ComBoox system. Thank you, everyone. See you in the next video.